trig equations is really, well, the way I do it is very visual. I'm hoping that you are up for this visualness, because I think it really helps you also remember these graphs and understand where these numbers are coming from. Now, so in order to do this, you do need to remember the basic graphs. We need to remember the sine. This will be 90, 180, 270, 360. Now we also need to remember the radian version. So what would this be in radians?
Pi over 2, pi, 2 over pi, 2 pi over u, 3 pi over 2, 2 pi.
Okay, so they are the numbers that you need to remember. Okay, so 90, 180, 270, 360, and then pi over 2, pi, 3 pi over 2, 2 pi. So that's our sine graph. It starts at 0, goes up, down, down, up. And then our cos graph, same values, I'm not going to repeat them, but it starts up here at the 1, and then goes 0 down, 0 up. And then the tan, remember, is the special one. Now the tan doesn't come up as often, so most of the questions that I'm going to focus on are the sine and the cos. What happened with the value of here, 90? What's that known as? Asymptote. Asymptote, good. So these are asymptotes. And they're every 180 degrees, so every 180 degrees, at negative 90, 90, and 270, etc., etc. Now, the important thing that we also remember about these graphs is that they continue on and on in both directions forever and ever. Okay? So whilst we're looking at a little portion of it, we know that these graphs keep going on and on and on and on. Okay? Okay, so far so good. So that's just a recap of the graphs themselves. Here we're going to solve an equation. Let's remember what solving an equation means. What we're asked to do is we've said that sine x, so sine of something, is equal to 0.5. So we're trying to find which value of x would give us an answer of 0.5 if we were to type it into our calculator. So if we were to type sine 16, would it give us 0.5? If we were to type sine of 72, would it give us 0.5? So we're trying to find which value goes in here. Now, I say here the first answer comes from the calculator. There are multiple answers for these. Okay? How do we find which value we're looking for? If sine of x is 0.5, how do we find x? What do we use? How do we use our calculator? Yep, inverse sine, yes, of 0.5. So we type that into our calculator, and we get an answer of 30, if our calculator is in degrees. Now, side-stepping a little bit, remember, if this is on paper 1, you are required to remember some of those answers. You remember the special triangle stuff?
Yeah.
Yes? So remember that if you've got some of those values, then you're looking at the only answers that you're going to have for this would be 30, 60, could be 90 or 0. But you're looking at those 30, 60, 45 values. Alright, so you do need to remember that if it was on paper 1. Okay, but we're going with a paper 2 situation. So we know that the first value we've got is 30. Okay, now, what I'm going to do now is sketch the graph of a sine curve. Now, when I say sketch, this is obviously not a sketch, this is a fancy proper diagram. When it comes to sketching them, I'm literally talking about a sketch. 2 seconds, I'm going to do that. Alright, it's really not, it doesn't take a long time. So then what we do is, okay, we want to find when our sine curve is equal to 0.5. What that means is that we find 0.5 on our y-axis. Okay, so that's going to be here, obviously, halfway between 0 and 1. On my sketch up here, it's going to be around here. And we draw this horizontal line at that value. Now, if we're trying to solve sine x equals 0.26, it really doesn't matter how accurate you are at drawing your value. As long as you've got it in the positive section if it's positive, and the negative section if it's negative, it really doesn't matter how brilliantly you draw it. Okay? So even this is pretty rubbish. That was supposed to be 0.5, but it's clearly not halfway between them at all. But it'll do. Okay, so it's just a visual aid for you. So here we go at 0.5. Our calculator gave us this answer here. You all happy with that? So we knew that this value here is 30. What we're going to now do is think about the symmetry of the graph. We knew it went up and down, down and then up. So we can see that this portion here is symmetrical, yes? Mm-hmm. So this here represents 30 degrees. Can we all appreciate that this arrow here also represents 30 degrees? Mm-hmm. Yes? Jennifer? Say no if you don't, honestly.
Can you say that again, please?
So our calculator gave us a value of 30, yes? So we know that this arrow here, where it first hit it, must be 30 degrees. Yes, because we drew our horizontal line, it meets our graph at this point here, so that one must be the 30 degrees. Makes sense because it's a small number. We now need to find this number here. So we can see hopefully that it's symmetrical around that point there. So if this bit here is 30, then this bit here would also be 30. Yes? Which means that this other value, the second value we've got, is 150. So if you typed into your calculator sine 150, you should get an answer of 0.5. Okay? So far, so good. So the symmetry of the graph shows the second solution is at 150. So if we were given the question, solve sine x equals 0.5 from values between 0 and 360, we would give our answers as 30 and 150. Okay, that's what our answer would be.
I'm just looking